This discusses how Cepheid variable stars can also be used to determine distances. The text reader will continue mispronouncing the term. Cepheid is actually pronounced like Cepheid. Cepheid variable stars are stars that, near the end of their lives, begin to undergo very regular pulsations with very constant pulsation periods, the time between pulses. These stars are larger than the Sun and can thus be seen at fairly large distances. They have an interior temperature that is on the boundary of singly ionizing helium, removing one electron, and doubly ionizing helium, removing both electrons. This causes outward radiation to be periodically trapped and then rapidly released. The result is that the star periodically brightens and dims with periods that range from 1 day to over 100 days. This particular star in the Large Magellanic Cloud has a period of 50 days. These fluctuations can last 1,000,000 years or so. It turns out that the period of pulsation and the average luminosity, and thus the average absolute magnitude, are tightly correlated. The period luminosity relationship between a Cepheid variable star's pulsation period and its average absolute magnitude was discovered by Henrietta Swan Leavitt in the early 1900s. As seen in the graph, the longer the period, the greater the average luminosity and the smaller the absolute magnitude number. Recall that smaller the value of the absolute magnitude number, the higher the luminosity. Absolute magnitude can be found graphically, like in the discussion of spectroscopic parallax. One can measure the average apparent magnitude and the pulsation period of a Cepheid variable star. Using the star from the previous slide, we have a measured pulsation period of 50 days and suppose this star has an average apparent magnitude of 23.9. To graphically find the star's absolute magnitude, locate the pulsation period on the horizontal axis, as shown. Then, move vertically from there to the line representing the period luminosity line. From there, move horizontally over to the vertical axis and read off the absolute magnitude. In this case it is about 10.4. Plugging the apparent and absolute magnitudes into our familiar formula, we calculate a distance of about 5,000 parsecs, which is the distance to the Large Magellanic Cloud. The Cepheid variable method is useful out to about 10 million light-years. Edwin Hubble, the American astronomer who discovered the expansion of the universe, used Cepheid variable stars to determine the distances to nearby galaxies.